Tonight, you're going to open an app without thinking about it. A message will arrive in under a second. You won't wonder how. You won't wonder why it works. But the real answer is far stranger than you think. The internet was never supposed to work this well. It was built as an experiment, a patchwork, a system stitched together by researchers who assumed most of it would fail. And somehow, decades later, billions of people rely on it every single second of every single day. Let's go back to the beginning. In the late 1960s, a small team funded by the American military built something called ARPANET. It connected 4 computers. Just 4. UCLA, Stanford, UC Santa Barbara, and the University of Utah. Nobody involved thought they were building the future of human communication. They were trying to solve a much smaller problem. How do you let separate computers talk to each other without one central machine controlling everything? That question matters more than it sounds. Because if one machine controls everything, one failure breaks everything. So the researchers designed something different, a network with no single point of control. Information would break into small pieces, travel independently, and reassemble at the destination. If one path failed, the pieces would simply take another. This idea came from a computer scientist named Paul Baran, who was working on a related problem for the Rand Corporation. He proposed something called distributed networking. Instead of one central hub, imagine a web of countless smaller connections, each one able to reroute around damage. At the time, most engineers thought this was unnecessarily complicated. Why build something so messy when a simple central system was so much easier? But messy turned out to be the point. A simple central system is fragile. A messy, decentralized one is resilient. And resilience, it turns out, is what let a 4-computer experiment grow into a global nervous system, connecting billions of devices. Here's where it gets stranger. The protocols that make the modern internet function were never designed for the scale we use today. Vint Cerf and Bob Kahn, 2 researchers working in the 1970s, developed what's now called TCP/IP. In plain terms, this is the set of rules that lets computers agree on how to send and receive data, no matter what kind of computer they are. It's the reason a smartphone in Tokyo can talk to a server in Berlin without either device needing to know anything about the other's hardware. Think about that for a second. A protocol built when computers filled entire rooms is still, today, quietly running underneath every video call, every online purchase, every message you send. Nobody expected it to last this long. Nobody expected it to scale this far. And yet it does. Every day. Without most of us noticing. So how does a single web page actually reach you? It doesn't travel as one piece. Your request gets broken into small chunks called packets. Each packet takes its own path across a web of routers, servers, and cables, sometimes physically crossing oceans through fiber optic lines laid along the ocean floor. Then, on the other end, your device reassembles all those pieces back into the page you see. If even one packet gets lost along the way, the system doesn't crash. It just asks for that piece again. Doesn't that seem almost too forgiving for something so massive? This forgiving design is intentional. The internet was built to expect failure constantly, everywhere, and to route around it instantly. Individual pieces are allowed to break. The system as a whole is designed to survive that breakage. Compare that to the way older communication systems worked. Traditional telephone networks used something called circuit switching. This meant a dedicated line was reserved between 2 callers for the entire length of a call. If that line failed anywhere along its path, the call died completely. There was no rerouting. No self-healing, just failure. The internet abandoned that idea entirely, and in doing so, it created something almost biological, self-repairing, distributed, redundant by design. Here's the twist most people never consider. The internet doesn't actually have an owner. No single company runs it. No single government controls it. It exists as an agreement between thousands of independent networks, all voluntarily following the same protocols so that their systems can talk to one another. Researcher Barry Liner and several of his colleagues, who helped document the Internet's early history, described this as one of the Internet's most radical qualities: cooperation without centralized authority. That should not work, and yet it has worked, continuously, for more than 50 years. Consider what that actually means. Every message you send, every video you stream, every payment you make online is passing through a system with no central authority, guaranteeing it will function. It functions because thousands of separate networks agreed, decades ago, to speak the same technical language, and they've kept speaking it ever since. Now, here's the modern mirror. Think about your own daily life. You wake up, you check your phone. Messages arrive instantly from people scattered across different cities, countries, even continents. You don't think about the packets. You don't think about the routers. You don't think about the fragile compromise of protocols holding all of it together. You just expect it to work. That expectation is, in itself, a kind of quiet miracle. A system nobody centrally controls, built from technology older than most of its users, running constantly in the background of modern life. The psychologist and internet researcher Sherry Turkle has written about how deeply we've come to depend on always-on connectivity, often without recognizing how strange that dependence actually is. We built something we didn't fully expect to last, and then we built our entire lives on top of it. Every time your phone reconnects after losing signal, that's decades-old design philosophy quietly doing its job. Every time a website loads, even when one server somewhere is down, that's redundancy working exactly as intended by engineers who have long since retired. Every video call that survives a dropped packet is proof that failure was expected, planned for, and absorbed before you ever noticed. Isn't it strange that something so essential to modern life was originally just a fragile experiment between four computers? The Internet doesn't work because it's perfect. It works because it was designed to expect imperfection everywhere, all the time, and to keep functioning anyway. So tonight, when you open that app without thinking twice, remember what's actually happening underneath. A network with no center. A system with no single owner. A design built from failure, held together by cooperation, running quietly beneath a world that has learned to expect nothing less than instant, effortless connection. Because the truth is, the Internet was never supposed to work this well. It just does.